University and Chile. Look at this. What happened? Oh. We look at this. This headphone is big, heavy, and hard to carry. So we done this. It's very, very tiny. Only just like this. How tiny it is? Look at this. It's an iPhone. It's just like this. But look at this. It's much bigger than the iPhone. But our headphone is very tiny. So when he works, he can become like this. The band and the crusher can be filled by air. The structure inside it to make the long life, long battery life, we inside the double battery in both sides, and the PCB control the band system, just like this air band. It can be controlled by the system, and the motor can be easy to buy on the eBay, and iPad. Their iPad is made by and battery in both sides. We know the headphone must become so great. So we designed the variable responsibility. How it works? It's inside this, made by MEMS technology. Electric control reflex unit. The unit can be programmed and change angle to change the reflected wave direction. So the sound wave can be selected in controlled path. And how we can control the band? With a motor drive it, make this length or long or short, and a air pump make it be filled. This band can reduce the painful from stress. It is emphasis about the stress. Look at this. The stress is afforded by there, not your ears. And this is a movie. The culture is be filled by the air to become big, and there the band is be filled by air and become small. This can adapt your hand of shape. Our hand for comfortable, flexible, beautiful music. It's easy to carry. Thank you.
You are one of my team. I just can say you work very, very hard. I heard you just go to sleep at 7 a.m. So you just sit for 1 hour and prepare for everything. So that's the problem. This is design, not product. Because based on your mechanical engineering background, you like to use the mechanical theory to approve your product is available to manufacture. I like this. And all the mechanical theories can support your system, but the shape of your headphone is not very like design. Maybe you can change your design to more build like artists, not just for mechanical. That will be better. So you are very work hard. I hope your design can be maybe commercial sometime, because you can buy anything in your headphone, like your part, iPhone, your motor can buy from the website means your idea is can be done. Sometimes we say how to how to make your product. You can say this is a very like the final design for the industry design, not just for the idea. Okay, thank you.
Yeah, I'm very impressed by the amount of mechanical detail you went into with the presentation. You even went as far as like pricing the components, which is kind of amazing. We didn't expect that. Yeah, I think as you said, like I think you really focused a lot on the engineering side of things, and I think you came up with an interesting kind of concept for how to change the way headphones work and how the portability and comfort can be improved. You know, and those are good problems to solve. So I think it's a nice, came up with a nice problem. Solution is interesting, but at the end, I think it would be interesting to see a product that's a bit more, looks more like the aesthetics and the kind of the attraction to the user. Right, this is like a mechanical solution, but it's also we're also looking for a design solution. It's like, why would I want to buy this? You gave some practical problems and some solutions to those, but I think in order to be a commercial product, it would need some more development in terms of finding the right audience and then finding the right look and feel for the product. But nice work. Look, yeah, you obviously put a lot of hard work into this.
So I think in terms of, like, in contrast to what, you know, how most of the other teams were working, you stated your problem a little bit more pragmatically, right? And you also used a much more kind of functional approach in terms of how to resolve that. I think some of the imagery that you showed us in terms of the, you know, like simulation and you know, it seems it's an interesting trial, but I'm not sure they're very convincing right now, right? For instance, why would you need to apply this kind of reflective sound wave system when, you know, maybe the most direct approach is in fact much more efficient, right? I mean, what is the reasoning behind that? You're adding a lot of complexity that doesn't really need to be there. The other thing is that, well, what is, you know, you stated the problem, right? Your problem is that it's big, but there are, I mean, I've seen lots of earphones smaller than that, right? And there are tons of earpods smaller than that. So what exactly is it about this that people would want, right? Besides because it's small, right? Or besides it's portable, right? There needs to be something more for that product to really be convincing, right? And I think that part is still not so clear. So I appreciate that, you know, you thought of some kind of more kind of novel ways to address the solution using kind of inflatables and whatnot. But I'm not convinced yet that that's something I really want, right? And I think that's the part that you can work on a little bit more.
Okay, I think people have their career, their purpose to do. So you have done such a lot of research of this project, right? And you work really hard, and we thank you to use Bridgen to such a lot of different functions. But I think you need to find someone, another designer, to help you. If you want to go to design any product, maybe next time you can go to ask someone. And I have a suggestion that you can go to learn someone from a website or from all around the world, and you can try to find a great step to design your product for this kind of competition. Okay, thank you.
Thank you for your presentation. And next, welcome our last team from Taiwan, 周冠慈、廖佩成、狄电伦。